Hello, in this section we're going to build on what we call a library of parent functions. A parent function is the simplest form of a function. It's the starting point before we apply any transformations like shifting or stretching. As we go through this lesson, I want you to focus on the shape of each graph and how the function behaves as x changes. Because once you recognize these patterns, graphing will become much easier. Let's get started. Let's take a look at what we're going to cover. We'll begin with linear and squaring functions, which are the foundation. Then we'll move into cubic, square root, and reciprocal functions, which introduce new shapes. After that, we'll study step functions and piecewise defined functions, which behave differently because they are not continuous. And finally, we'll focus on recognizing graphs quickly. That's the goal, recognition. We are given 2 points and asked to find the equation of a line. First, we calculate the slope. Change in y over change in x. Once we have the slope, we plug into point slope form and simplify. This gives us the final equation in function form. The key idea here is we can build a linear equation from just 2 points. Now let's look at two special linear functions, the constant function and the identity function. On the left-hand side, you'll see the constant function. F of x equals some constant c, or y equals c. This is a horizontal line. That means the output never changes. On the right, you see the identity function. F of x equals x, or y equals x. This is a straight line through the origin. Whatever you input is exactly what you get out. Now we look at squaring function. F of x equals x squared. This creates a U-shaped graph called a parabola. Some important features are that the domain are all real numbers. The range is only non-negative values, and it has a minimum at 0, 0. And lastly, it is symmetric about the y-axis. Why symmetric? Because negative numbers become positive when squared. Next, the cubic function. Now, f of x equals x cubed. This graph has an S-shaped. The key ideas here are that it's increasing everywhere. It passes through the origin, and it is also symmetric about the origin. Unlike squaring, cubic functions keep the sign. Now the square root function. F of x equals the square root of x. The key ideas here is that the domain x must be positive or 0. The range or the outputs are also non-negative. It starts at 0, 0, and it's increasing slowly. Please note that this graph only exists on the right side because we are taking the square root. Next is the reciprocal function, f of x equals 1 over x. The key ideas here are that this function is undefined at x equals 0. It has no intercepts, it has 2 separate branches, and it is symmetric about the origin. Please note that this graph approaches the axes but never actually touches them. Now the step function. This is f of x equals the floor of x. What does floor mean? It's the greatest integer less than or equal to x. So in simple terms, you take your number and you move down to the nearest whole number. Some examples include the floor of 2.7 is 2, the floor of 1.2 is 1, the floor of negative 1.2 is negative 2. It's important to remember that this is not rounding. It always rounds down. Some important features of the graph include that it looks like steps. It's flat between integers, and it also jumps at each integer. Let's evaluate f of x equals the floor of x plus 1. We do this in 2 steps. First, we take the floor, and then we add. So if x is 1.5, the floor is 1. Then add 1, which the result would give us 2. To say this clearly, we first take the floor, then apply the rest. Now we graph a piecewise function. Each part of the function applies to a specific interval. At the boundary point, one rule includes it, the other does not. If it is closed, if it's included, if it is closed, it is included, if it is open, it is not included. This is how we handle functions that change rules. Let's bring it all together. These are the main parent functions: linear, quadratic, cubic, square root, and reciprocal. Each has a unique shape. Your goal is to recognize them quickly.